Morning, students. Today we are going to be constructing two different things, the Circumcenter and the Incenter. So 6.3, we're on page 199 to take notes. So we're going to be taking notes on page 199 and 200. And first we are going to be constructing a circumcenter. And a circumcenter is a circle that circles an object. So this goes outside the triangle. So a circle outside the triangle. And what you use for this is you're going to be using perpendicular bisectors. So yesterday we learned what perpendicular bisectors were. They bisected, they made two equal parts, and they were perpendicular from a line. So we're going to use perpendicular bisectors to draw a circle on the outside of the triangle. Now, an interesting thing about this lesson is in the homework they don't draw the circles for us. So I'm going to teach you how to draw the circles, and that's going to allow you to tell what's equal and that kind of thing. So perpendicular bisectors. The first piece we need to do is we need to bisect each one of these. So I'm going to measure this is 1.5, so 3/4. So there's our bisector for that one. And then I'm going to make it perpendicular, and so that would probably be about that line right there. So there's a perpendicular bisector. Now I'm going to find the middle of this one. This is 2 inches long, so 1 inch, there's the middle. And then I'm going to do a perpendicular line. Oops, I should have made this line a little bit longer. Uh-oh. Well, let's hope that that's the middle. I mean, if my measuring lines up right, that will be the middle. So I've got, this is 2.5. So 2.5 would be 1.25. Hot dog, there's the middle. And perpendicular be right here. So my circumcenter for this one actually lands on this line, but it usually won't land on this line. And so, I'm sorry, I forgot to tell you, you're going to use 3 tools for today. You're going to have a protractor, a ruler, and a math compass. So circumcenter, it's a circle on the outside of this triangle. So I can put it on here, and I can put my pencil on any one of these points, and it should hit each one of these points exactly. So if I can hold it without moving it, this should make a circle that hits each one of these points. Oh, and I broke my lead. But there it is. Perfect. It does. So this is the center of my circle, right? And so what this shows is that this line I wish it wasn't right on this line, but this line, let's call this A, B, C, D. That AB equals AC and it also equals AD. AD. And the reason we know they're all equal is because it's the radius, right? AB is the radius of this circle. So this line segment AB of this triangle equals this line segment AC, which equals this line segment AD. Now, let me show you one that is not a perfect. Right here we have another example because I want to show you that it doesn't always land on this line. So here we have this point, and let's see if I can do this with broken lead. So I'm going to put this on here, right here. Try and lightly draw it so I don't mess up the lead. So you see that my center right here, so here's a perpendicular bisector. Here's a perpendicular bisector, and here's a perpendicular bisector, and they meet right here. So from that point, I drew a circle, and then from there, I took the radius. So I have this line AP. So it goes from the corner to there. So AP equals here to the vertex, PB, which also equals AC. So it helps if you could differentiate with color or a pen and a pencil that AP, BP, and PC are all radii of this circle. And PF and EP and DP, those are all perpendicular bisectors. So the takeaway from this is that these that go back to the vertex are all equal. So if you were to have something like 2x plus 10 and 3x plus 5, you would be able to say, oh, well, PC equals BP, and you'd be able to make this 2x plus 10 equals 3x plus 5, and you'd be able to solve that and get you'd be able to get x equals 5. You'd plug it back in. 2 times 5 is 10. So this length would be 20. And it should equal this length, which would also be 20. So the key part to remember is that circumcenter goes with perpendicular bisectors. So if you see in our homework, it says perpendicular bisectors, then you're going to know you're going to be working with the circumcenter. Or if you see circumcenter, you know you're going to be working with perpendicular bisectors. So it's going to be important to refer back to your notes. Because the other one we're working with today is Incenter. Incenter. The Incenter theorem. So what this is, so we'll say Incenter theorem is a circle inside the triangle. So this one is a circle inside the triangle, and this one is dealing with angle bisectors. So if we're doing incenter, we're going to be working with angle bisectors. So the difference, angle bisectors or perpendicular bisectors. So let's see how we figure out angle bisectors and what that does for us. So now I have to use my little protractor. So if you remember, you're going to line up this hole right here goes on the, so that vertex right there, you got to put the hole right on there, and you have to line up this 0 with that line. So if I look up here, I've got 25, 6. So it looks like 6, 7. So 25, 26, 27. So this angle is about, I'm just going to say 26. 26 degrees. So half of 26 is 13. So I'm going to mark 13. 10, 11, 12, 13. So there's my 13. I'm going to take this angle. Oops, I'm sorry. Pulled it out of the view. So I'm going to start here, and I'm going to take this angle right here, which is so there's 0. So don't forget, you're always starting from 0 and going this way. I mean, you're starting from 0. So I wouldn't be starting from 180. So I'm not counting this 130. I'm starting from 0. I got 55. So this angle is 55 degrees. So half of that would be 22 and a half. No, 26, 27 and a half. So I want to find 27 and a half. So I'm going to split this angle. So I'm just finding the angle bisector right there. So I'm cutting this and this. Now when I find the angle bisector of this, it should run right around there. So let's go up here. I'm going to measure. So I'm measuring from that vertex right there. My protractor on it. I line it up with the 0. And this one's going to be more difficult because I can't see. Let's run this. Let's take it out a little bit longer so I can see it. So it's going to hit at, start at 0. We've got 80, 90, 95. So that's 98. I'll take it at 98. This is 98. So that is going to be 49. So the half of 98 is 49. So I go here, and I go to 40, 50, 9. So I line it up with that dot right there. And boom. It's pretty close. Pretty close. So there's my center right there. And we are doing incenter. So it's a circle inside the triangle. So that point right there, when I'm using angle bisectors, that point is going to take me to the middle of the inside. So I find where it hits the inside. So I'm not going from the vertex. I'm going where it hits the inside. So this should give me, oh, my leads. The lead's pretty broken. If I go the other way, work better. Close enough. So there's my circle. You can see my circle. I will sharpen this to get a better. So now I have the in circle and touches the sides of my triangle. Now, if I were to make a line from the center of my circle to where the circle touches the triangle, it will actually land on a perpendicular line. Boop. 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 So those 3 lines, we're going to say A, B, C, D, E, F. So A, E, F, G. So we're going to say A, G equals CG, which equals GE. So basically the in-center theorem, all that's telling us is that if we have the circle inside, and if we draw the lines to our triangle, those lines are equal. And it's the same deal. You know that so that you can find, so that you can answer, you can find measurements. So when it's talking about in-center, you're going to use angle bisectors, and you're going to find it. So here we have angle bisector. So AP is an angle bisector, CP is an angle bisector, and BP is an angle bisector. So if I were to take a functioning compass, I were to draw, oh gosh, again, the lead, there we go, they're cooperating a little bit. Draw a circle in there. I see that the lines from the center of the circle to the triangle. One, they're perpendicular, but two, they all equal each other. They equal each other. So if you're doing incenter, you're going to get these radii, and they all equal each other. And they go perpendicular to the lines. If you do circumcenter, you don't get the lines that go from the center to the vertexes are all going to be equal. Okay? So let's see how that plays out. So we've got right here, what do we have here? It looks like we have, well, it's not coming from the angles. So is this perpendicular bisector or angle bisector? Well, this is perpendicular bisector. So, because it's a perpendicular bisector, I'm going to look. Let me see. Oh, nope, it's not an angle bisector. It is a perpendicular bisector. So I'm going to be dealing with this. I'm going to be dealing with the circumcenter. So just to make sure I understand it, I'm going to draw a little with my broken protractor. And I'm also going to label this ND 2x minus 5. In E is negative 2x plus 7. Find NF. So what's this length? Well, what do I know about these two? Well, they're equal. So 2x minus 5 equals negative 2x plus 7. So let's make the x positive. So I add it on both sides. I get 4x minus 5 equals 7. Add 5 to both sides. We have 4x equals 12. Divide by 4, x equals 3. Great, so NF is 3. Wait, no. I have to plug the 3 back in, right? Let's do it. Let's plug it in here. So 2 times 3 is 6, minus 5 is 1. So looks like NF is 1. Just because that doesn't sound great, I'm going to check it on this one. Negative 2 times 3 is negative 6 plus 7. Well, that's 1. So NF equals 1. So I used the perpendicular bisector. Actually, I used the circumcenter to know that these two were equal. So that's why we did all that. So I know these two are equal. So let's go here. So we have the perpendicular bisectors. Bum, bum, bum. And so, oh, I'm sorry. I apologize. It tells us right here. It's the Incenter. Oops. So they did all the work for us. This is actually the Incenter. They did all the work for us, and it turns out it's the same. ND equals NE. So we got the correct answer. So these are all incenters. So here we know, because it's an incenter, that this equals this equals this. So we have x plus 10 for in K is x plus 10. In L is negative 2x plus 1. I know they're equal because we're working with the incenter, so I have x plus 10. Sorry, I'll take that out. It's not the perpendicular bisector. It's the incenter. So x plus 10 equals negative 2x plus 1. Let's add 2x. So we get 3x plus 10 equals 1. Minus 10. So we get 3x equals negative 9. Divide both sides by 3, and I get x equals negative 3. Great. Now I take that negative 3 and I plug it back into here. So negative 3 plus 10, that would be 7. And just to make sure, I'm going to plug the negative 3 into here. Negative 2 times negative 3 is positive 6 plus 1, that's 7. Okay. So NM equals 7. All right. Let's check out how to use. So this looks like angle bisectors. So here we're using angle bisectors. So thanks to the angle bisectors, it lets us know that this is equal to this. Oh, wait. Find the indicated measure angle bisector. So that gets this. But which makes these all equal. So if PU equals 8, then PS equals 8. And how do we know that? We know that because of our angle bisector. We know that PF equals PE equals PD. All right, here we have an angle bisector. So we know that this equals this equals this. So NF equals 2. Sounds good. All right. These ones are cool. Find the coordinates of the circumcenter of a triangle with the given vertices. Okay. So these are all positive, and we got a big one. So I'm going to start over here. And no negatives, so I'll just start it down here. 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. 3, 1. 1, 2, 3, 1. 9, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. So there's our triangle. Right there. So we got to find our circumcenter. Our circumcenter is perpendicular bisectors. So perpendicular bisectors. So let's bisect. So this is 1, 2, 3, 4. So there's our perpendicular. There's our bisector, and perpendicular would just be straight this way. And we got 1, 2, 3, 4, 5, 6. So 1, 2, 3. Perpendicular. Hey, look at that, it's landing right there. So hopefully that's the middle of this one. I'm going to assume it is. But what I can do is yep. So it's the middle this way, and the middle this way would be right there. So got it. And then circumcenter. Oh, we just need to find the coordinates. It's where these lines cross. So this point right here is 1, 2, 3, 4, 5, 6. 1, 2, 3. So our circumcenter is 6, 3. There it is, 6, 3. All right, give those a go, and I'll have a practice sheet on there for you also. And let me know if you have any questions.